Yeah. Anyway, so today I'm talking about two things. I'm talking about OpenStack and DevOps from the gentleman in the back that San Diego Supercomputing Center is going to OpenStack, which it's sprouting up everywhere, so it's a very timely topic. So the other thing, you see earlier that Java is 20 years old, OpenStack is 5 years old. They have birthday parties all over the country, especially that actually have people with a lot of OpenStack, like Silicon Valley or somewhere. But just with the numbers, they have 27,000 members, they are in 167 countries, and they have 123 local groups, so they're big thing coming. So I want to talk about what is Scout and all those things. Picture from the OpenStack Summit in Paris. So they come around, we go around. But let's talk a little bit what is Scout and where does OpenStack fit in and where do we developers fit in. So basically there are the three types. We have software as a service, basically what Salesforce is doing, what Gmail is doing, all those people who log in and don't really understand how they run it, whatever. You have platform as a service, which gives you then the building blocks to build, as they say, cloud native applications. You have a database, a little bit what Amazon's doing. A database, you have a queue, you might have a cache, and all those things, and then throw them together, so you don't really have to think about how to run, let's say, database, which was there. So that's basically, as it says here, for app development and things like that, build on it. And then you have infrastructure as a service, where basically you get a box and maybe network and stuff, and you have to install your own Ubuntu or whatever you want to install, Windows, if you have the licenses, and build your own stuff on top of that. So those are three flavors of cloud, and everybody is. And OpenStack, they mostly fall into the infrastructure as a service kind of track. So, but let's start again. OpenStack is not a single open source project. They're actually a collection of lots of open source projects. They're not a hypervisor, so they virtualize things like VMware. They have one hypervisor. OpenStack, you can use any hypervisor you want and support it. Like the VMware support, Hyper-V support, and KVM and all the other free ones, Xen and CVM. So the storage platform, though it started sort of out of that, so it can do much more. And it's not necessarily competitive with VMware, though a lot of people going to OpenStack to save on VMware licensing costs. A lot of people think they can save money, and it's probably true, and then they install OpenStack just to use it for server virtualization. But it's not really where it's at. And what is it? It's on the Wikipedia page. So it's a free and open source software, cloud computing software. And as I said, it's mostly infrastructure as a service. And it's a technology related projects. They control everything, processing, storage, networking. And then they have a web-based dashboard, a command line, RESTful APIs, you can script things. And OpenStack releases everything under the Apache license. So all the projects are under the Apache license. So you can use them, you don't have to pay anybody money, and all this stuff. And now let's compare it. It's basically Linux of the cloud. So it's basically like Linux used to be. You had to get all the different hardware drivers, had to compile them yourself, had to put a lot of work in it, and then you got Linux. And it's basically the stage they are in, so they're not really there. You just download some Ubuntu and all happens, or Fedora, or whatever. It's just there. There are people there making distributions, but it's still in its infancy. So probably there's a few years to go till it gets to the ease of use where Linux is today. Probably should also talk a little bit about the history of it. So it got developed by NASA. So the problem they are trying to solve is they So when NASA does a new project like flying to Mars, and it takes like 10 years, then they get the money right from the get-go. So they get in their $1 billion, and then they have to buy computers right at time, otherwise the money is gone. Then they have the computer sitting at a data center, and then one day the thing makes to Mars, and then they can use the computers to actually do whatever they need to do with that. That's very, very inefficient. And so they then invented OpenStack so they can share resources for the projects. They can basically shift it around, and which project is hot at the moment can have more computers than it could actually have bought with this project money. So one thing. And another place where it's used a lot is CERN, up in Switzerland, because all this collider stuff needs a lot of computing. And then basically NASA got together with a company called Rackspace down in San Antonio, and they kind of started to sort of commercialize it. And when we look at OpenStack today, it started out with compute and object store in the beginning. So this is compatible with basically what S3 does in easy elastic. S3 does in Amazon, if you're familiar with that. But if you go through there, they now have everything. They have compute, networking, object storage, block storage, identity, image, dashboards, telemetry, heat, orchestration. They put everything in there. They're also keeping ADU capabilities so they meet twice a year, and every time they have new stuff, like now have queues, they have a shared file system work on, the DNS service and key management. And the way it's structured, they have a foundation. Basically, most open source projects have a foundation. The foundation is people who can govern it. They have elections for a technical committee, and they have people who contribute in an open source way. And of course, a lot of them are paid by companies. But let's go through a few of those things. So Compute Nova is probably the most important thing to use. It's similar to EC2, what Amazon does. And in fact, in the beginning, they really try to be API compatible with Amazon, because they want to have people kind of give them an alternative to Amazon. And as I said, can leverage multiple hypervisors, Xen, KVM, vSphere, Hyper-V. vSphere is the VMware one. And it's also made up of several subcomponents, Nova API, Nova Compute, Nova Schedule. And in fact, Nova used to be this big monolithic block. And a lot of things in the world kind of grow and grow and grow, and they did it differently. They keep spinning stuff out to its own sub-project. So when things get more, for instance, the Nova schedule, so scheduling VMs on hosts used to be a simple problem, and then people wanted more and more complex things. Then they said, okay, let's spin that out so people can focus on scheduling. So then they have the Swift thing, which is, as I said, similar to Amazon S3. And it provides basically distributed object storage. So you can upload stuff and make your application needing that. And it supports the OpenStack API, and there's HTTP. So if you have something like CyberDuck, you can upload things in there and out there. There's also a bunch of storage vendors have API compatible stuff. So if you don't trust open source software, always go to one of those storage vendors like the EMC or what does that. Then there's an image catalog. So one of the things in the cloud, you need to kind of organize your images. So there are basically two ways of doing software deployment in the cloud. One is that you kind of bake images which have your software on them. So you would have like an Apache image with your web server, maybe a Tomcat image with your Tomcat, and the application baked in, and then that's what comes out of your build system, and then that's what you would put into your image catalog, and then deploy just kind of started image. The other thing you can do is just use standard operating systems like a Linux image, and then you run scripts against it which install all the things you want. So the Apache Tomcat all start out as Linux images or Windows images, and then you run a script which knows this should become the Tomcat image, Tomcat server, and then you run scripts. And so this image catalog allows you to basically upload images, like base images it like the operating system or can make your own. And also, as I said, has the image storage, retrieval, and the discovery of things. And these images are then leveraged, as I said, to launch the virtual machine. So they are launching those images. How that works. And they have another thing, the identity. So OpenStack is a lot of geared towards corporations, so that they can have their internal cloud, like supercomputing center, not a corporation, but want to have an internal cloud, I guess. And so you want to be able that the people work at your corporation, that they can log in and kind of do stuff there. And Keystone, they provide a policy of education services. So for the other OpenStack services, not everybody can upload images or files or start VMs. And you can, and basically it kind of, it's a pluggable architecture, so you can hook it up with, you have an LDAP or the Microsoft thing, Kerberos, or whatever they have there. You can hook it up with your existing kind of user directory. You don't have to give them new accounts, which is always good to not have too many accounts. And then we have block storage came there. So basically the way, like most cloud things actually are, is you have a VM, it has a file system, you put stuff there. For some reason the VM dies, maybe you stop it and then everything's lost, which is not ideal for some situations. And so there's then a way to have block storage, so which then stays there forever until you delete it, so which survives basically the life cycle of virtual machine. And that's important when you want to do things, of course, and that's sort of slower than if you would have a real server for hard drive in it, because they have to kind of get it from somewhere else over the network. And basically, it leverages storage drivers to go to under your underlying storage platform. So if you put out a big money, buy some EMC or whatever, then they will give you a way to use that with OpenStack. And that's basically also one of the motivations why people use OpenStack is so when you look at the whole computing world, on the one side you have developers and users who expect everything to look like Amazon or any cloud service where you click a button, you get your VM, or you click a button, get your storage. You don't really want to do a ticket and wait 4 weeks until somebody buys the server and racks it and connects it, and whatever else can happen. So you have that challenge. On the other hand of OpenStack is that IT departments have less and less money. They can't just go out and buy a lot of stuff. So they need to be very smart with their money. And so OpenStack allows them to kind of, because everything looks the same to the people, they easily swap out things. So if they would like have an EMC storage thing in Cinder, and for whatever reason somebody gives them a better deal, then they can just swap out EMC for somebody else behind the scenes without changing it for us developers. Whereas before, there's no change for us because we use the OpenStack kind of API. It looks the same for us, but the IT department can sort of standardize, can sort of swap things out as they see need or where there's economic opportunity for them. And also, if they really want to do that, some places like Walmart always have 2 vendors. Just can manage that and can kind of say this guy's cheaper, whatever. So basically that allows you to do that without a change on the developer side. So it's very attractive for IT departments to go there, because suddenly you can sort of commoditize your IT infrastructure. And you see that in a lot of areas happening. Of course, when a lot of vendors are involved, then the API ends up to be becomes the least common denominator, because each vendor wants to make sure that his thing plays nicely with it, and if there's a special feature, and the other vendor doesn't have it, then they usually get together and decide to do just what everybody does, more or less, because nobody wants to give his competitor an advantage. Hey, play there because they have a special feature we don't have. And so yeah, it's always two sides of the coin. And then we come to network Neutron. This is where I know the most about, and it's also where Java comes in. So basically, a big problem when you run VMs. Is that when you want to. So basically, they run on servers, and sometimes you have to do maintenance on servers, but you want to do that in a way that nobody notices that. So you want to move all the VMs to another server and then do maintenance and move them back or whatever. So if you do that with standard networking, then that doesn't work because you have to kind of plug cables and reprogram routers and whatever else you have to do. And so they do something. Neutron does something which is network as a service. So they have they run a vSwitch. They use virtual NACs and stuff, so you can move things around. They use another thing which is called software-defined networking. And software-defined networking is basically one of the most exciting things happening in IT right now, because you can go and program routers, all the routers in your data center from controllers, and you basically can send out things over a standardized protocol. You can write programs which do stuff on those routers. The routers will talk back. So you can tell them, if you don't really know this packet, send it up to the controllers who can look at it and decide what to do with all those things. So it's very exciting. And the thing, when you see it before, you had to go to each router, you had to do cables, you had to do configuration, and now you have this central thing which controls it, which runs software. So you can basically opening it up for the DevOps thing, where you can write scripts to configure your whole networking software, networking infrastructure just with scripts. And the most interesting thing is the leading thing of the SDN world is called Open Daylight. That's written in Java. That's where we come in. It's all written in Java, so really exciting. And Neutron, basically, that's the OpenStack networking. They go on top of things. As I said, they go on top of Open vSwitch, which is another, it's basically a Linux switch, so it's running on the host. OVN is another software-defined networking thing, Linux bridge. Open Daylight I mentioned. Then you can have, of course, people like Cisco who are in the network space a long time. They also have plugins to plug in there and can get those stuff. And they also have, as under Neutron, they also have plugins for middle functions like firewall as a service. You can buy a firewall from a vendor. It looks the same in OpenStack as if, again, it doesn't matter which vendor. Same for LBAS, load balancer as a service, and the virtual private network as a service. So they put on everything, you might get it put as a service. The other exciting thing in that area, networking, is network function virtualization. And the telecommunications companies like AT&T, Verizon, and all those guys, they want to save money, and they kind of forced all those vendors who do firewalls, who do load balancers, who do VPNs, to give them VMs with their thing. They don't want to buy any hardware from them anymore and put them inside. Say, you guys have to sell us VMs. And they want to run all those VMs on OpenStack. So that's their big plan. So basically then if you happen to be somebody running, so you then call up AT&T and you need your office connected to the internet, then what they then do is they fire up a few VMs, maybe one for firewall, so not everybody can steal your data, and whatever else, maybe VPN, so can log in remotely. It's happening automatically. You fire VMs and it all runs in there. And of course, it requires again that you can do the network programmatically and don't have to send out people putting cables and whatever stuff. So lots of exciting stuff. Of course, having a telecom industry inside OpenStack, I told you earlier that it's not that mature. So that makes it very challenging, because those people, telecom people actually they want to have stuff which has very high reliability, is very mature, always works. So there's a lot of conflicts. And people say, let's change everything and go to this new thing, and then telecoms say, no, we need 5 nines. But yeah, a lot of people see a lot of potential in this telecom business. Hey, as we have the dashboard horizon, so this is what most people look at things. That's the web GUI. Basically control everything there. It provides a graphical user interface, what are OpenStack services, and leverages the API. Has been done previously, so OpenStack is maturing a bit, so it has been done all by developers who didn't know about UX. I don't know if UX is the big new hotness in our industry. It stands for user experience, and the people who have done that previously, they didn't really have user experience. So the user experience is poor of that to some degree, but it's being redone. So we at HP, we have our UX department, and they look at it from the user and try to make that better and more streamlined. So are the other people working on OpenStack trying to make that a more mature thing which everybody can use, and not people who went through training. So there's a lot of realism happening, and that's where the UX people kind of going. And the next, so right now it's a static web page thing, which is slow and everything. And the next version will use Angular.js. We'll have Elasticsearch. You can look for among your millions of servers you might be administrating. You don't have to scroll through. I told you people didn't think through it. You can now search. It all shows up. So it will be awesome. And I just went through the components which we are ranked. There's a couple more stuff. So basically the most important, there are a bunch of things, so I went through the most popular ones, but I also want to mention oscillometer telemetry, because usually people who kind of implement that in IT department, OpenStack thing, they often have this idea they want to recharge. So they are really interested in having metrics. So we can't really call it billing data. It's called metrics. So how many minutes you use a VM, how much data you pump through, then they can figure out how they want to recharge. The other thing is Trove is the database. Trove is the database. It's MySQL based, but they are now adding Redis and Mongo. So that's all coming. And then the data processing, Sahara, because somebody mentioned there's big data with Spark, is a big example. Sahara is there. It's the big data project in OpenStack. And those people, I know them, they work very closely with the Apache guys. There's I think something called so some Apache project they do, it's not Spark. And that's basically trying to get that I think everybody does. Divide them from the Hadoop, get Hadoop on this platform, yeah. So it's another important thing. Hadoop on there. It's a workload. We call it then the workloads. So there's a whole new language here and stuff, but they are working on that, getting Hadoop and those things in there. And there's a bare metal thing. So basically, when you ever dealt with servers, they're all different. That is a problem because then you have to think about a lot of stuff. So OpenStack also has a bare metal provisioning. So it basically takes the whole server and presents it to you in a unified way, independent if it's as free because probably see the CPUs, but it basically abstracts that for you, which is sort of important. And a bunch of the, I said earlier, there are distributions merging, like you have your Ubuntu for this, Red Hat and whatever else. And what a lot of these people do, they go install the bare metal thing, ironic, on all these servers you give them, and then they start building on top of that. So they don't have to deal with the kind of intricacies of different servers. So what's our new stuff coming? We have a queue service, Sakar. There's another queue, so another called queue, CUE. What's another thing about OpenStack is, as I said, it's a loose collection of open source projects. And because it's open source, a lot of people want to do the same thing, so you end up with projects which do the same thing, like Sakar and queue, and then it's kind of in the footnotes where they differ. So I think Sakar does Redis and queue does Rabbit, and so one is not this type of queue, other one isn't. Another interesting thing is the DNS service designate. So basically designate gives you a unique interface to DNS providers like Akamai, Power DNS, and all those guys. And that's, why is that important? Those guys charge different, first of all they charge different fees, so if you run a data center, you can save some money by switching back and forth. So we did that at HP, saved a few $100,000. You can buy something like that by switching from one to the other. And it wasn't a change, as I said, because of the API, it's not a change for the developer. It's still the same stuff, but allows people to change that. The other thing is they want to give everything. They want to now give everything a DNS name. There's a lot of that thing because people can't really remember IP addresses, so it's good to have DNS service in there. It's one of the core services. And lastly, what I want to mention is the key management, which is called Barbican. And what they do is they provide, they do actually two things. There's a central secret storage, and I don't know, probably RESTnet, you guys have secret data, nobody, probably HIPAA and all this stuff. And if you're in somewhere where have secret data, they usually use hardware devices which have hardware encryption on them and kind of keep your secret based on by some box, crypto box, I already call it. And Barbican is kind of the API for that. So it can, again, looks like one thing, you can have different crypto boxes. If you don't need crypto boxes, it goes on the file system, whatever else. So very, very flexible, very good. The other thing it does is it's also there when you're into SSL certificates, it allows you to, it hooks up with the RS8 of this world who have those certificates, and you can order them straight in OpenStack. So you can just go on your Horizon dashboard, say I need your certificate, they make the request, goes out to RS8, send it back, and then it's in your secret repository in a crypto box. So, really cool stuff. So, well, we should talk a little bit about the business case for OpenStack. So for most companies, that makes a lot of sense to sign up for public cloud and run their own is one. So I have talked about it years. I probably was here and said you guys all should throw away your servers and go to Amazon. But that's, didn't happen. And reality is that there are still more businesses treating servers like pets than cattle. And you see that a lot of people name their servers. They're not named 1, 2, 3, they're named whatever name, so they kind of care about them. And then there are people who's likely to be so because everybody says you go cloud 100%, as opposed to fire. Everybody works in this data center. It's difficult for the CIO suddenly. Just 2 people report to you who buy the checks to Amazon. Difficult place to be career-wise, I guess. So last thing, what this nice gentleman from Redmond. So anyway, unless tech leadership really wants to do the total war and fire everybody, that's not going to happen. And while infrastructure will be its thing, and people will need to embrace OpenStack. So 2 things. The guy who's written that is Steve O'Grady from Redmond. So everybody should go there, read his stuff. Very smart. His claim to fame is a book called The New Kingmakers, where he believes that software engineers like us can kind of drive all the decisions in the company. And or at least the buying decisions in an IT department, which is actually true. So I know from our HP thing that salespeople went to the IT department and said, okay, there's this OpenStack or whatever, on top that thing, and it looks like this. And they said, yeah, that's awesome. Then they went, and then And then they went to developers and said, no, we really love the thing P-Rodel is doing. And it came then bundled with some other person, so we lost the deal. So it's really the developers, so really the software engineers have that type of power. They're basically the new kingmakers who can win in this corporate IT landscape. So the other book he recently wrote is about software, and I haven't read, I only read the synopsis of this book. My life is too stressful or can't really read that many books. Anyway, the other thesis is that despite software eating the world, that is, was it Mark? Let's get right, said that software is eating the world, so it's everywhere. Everywhere, everything is now running software, cars, everything. And despite software being everywhere, the margins for software are getting tinier and tinier. There's less and less money to be made in software. But it's everywhere. So I guess, so basically you make it up in margin, whatever, no volume, that's always the thing, you make it up in volume. And just an example, when I looked in, when I gave talks a while back on software as a service, as opposed to on-premise software, and usually the on-premise margins are kind of obscene if I were to put it. But where software as a service, you like much lesser margins, about 10-20% margins there, profit margins, whereas with on-premise, which nobody buys, can calculate. Doesn't make good money, and so that's another indication. There's not that much money anymore in software, despite it being everywhere. Okay, and so where does where does OpenStack fit in? Well, so the big story is that in those big corporations, there are lots of software developers who might not necessarily be hooked up to the IT department. So maybe some people reporting to the marketing guys, making websites, doing them all on Amazon, and having customer data and don't really know, maybe PHP people, we always look down on them. Whatever, and then they lose all the customers' data, and then the reality is that then the corporate leadership doesn't go to the marketing department and says, "You guys did wrong, you'll all be fired." You should go to the IT department and say, "You guys, this is not computers, it's your domain. You fix it and get out." And so there's immense pressure for CIOs and all those people. Basically offer something which is attractive enough so you can get all those rogue developers on the platform. The business can control and enforce whatever standards they see fit. So no data is lost and everything is, doesn't go down or whatever. And so OpenStack has, it's the on-premise thing. So you can go like to a community center, you have your servers, you buy OpenStack or you download it and have people who know how to do it. Put it on there, have it on-premise. Another thing people are selling, there are not many people, probably HP, IBM, and VMware, and Oracle probably. Oh, it's not OpenStack, but what people are selling is that you have stuff in your own data center, and if you need more, then you can go to one of those managed data centers all over the world. People have get 2 racks, put OpenStack on it, and hook it up. Then there's of course a public cloud if you need to burst out to somebody. But there's no, the public cloud is a difficult business proposition for most companies who are not Google, Amazon, or Microsoft. And so there's less and less public cloud besides them. It's just very difficult to make money in the public cloud and fund things. Because it's a kind of a race to the bottom, and I always thought that a company who makes servers and storage and networking gear could compete there, but it's a difficult thing. Yeah. So basically it's all open source, and we are back to the distro days. Okay. Demo time. guys see that? Good. Okay. So the way the OpenStack people, they're easy on road. They call it DevStack because it's made for developers and it's broken most of the time because it's basically what they call in the business drunk. So anybody in this of those 100,000, let's say many thousand people write new code which doesn't work, then you get it. So that's the let's start fresh. So yeah, good. Here. So as I said, there's something called Nova. You can do something like Nova list, and I prepared this whole thing by starting a VM. And you see it has an IP address. They even fancy give you a IPv6 address. Give it a foreign name, it's an ID and stuff. Then we set it GANs. They have some command called images, so you can see what images we have. Most popular image is Ceros. Everybody installs it, it's very small because you see I don't have the biggest computer for that. And the other one is what we work on. Before stuff, so there's stickers outside of the project I work on called Octavia. You can put them on your laptop right there. Just the OpenStack logo. Then the other thing we have is Neutron. They have networks. And we have, I logged in as a demo account as a private network, as a public network. You can create more networks if you understand networking. You can make routers. You can make all the networking stuff you want. Again, you have 2.6 on those things. So let's see if you want to start something. So here I have a command to basically start a thing. So you give it an image. And since I do it a lot, I have a hard thing which figures out which zeros it is. Image ID flavor. One is, so it's basically, as you can imagine, there are different sizes. Flavor is the smallest. And then you can go to extra large, and extra large and even more. You have to give it a network ID, and it gets that out and tries to figure out the network ID of the private network, which is E1. Sometimes it asks for subnets, so it's always good to keep both around. As I said, it wasn't done by UI people and UX people, and I don't know if you guys are aware, there's a UX people who do command line stuff, so this is Docker. We'll talk about it later. They have a UX guy who tests different command line options with real audiences to figure out what's the most intuitive. So it's new for me, but that's just done by people, for people. But there too you can find user happiness. Anyway, let's give it a better name. Things. Now you see it's other stuff. So there's a security group, so per default you can't access anything, you have to add rules to it. So it's a deny. So the security paradigm deny everything unless you explicitly allow it. And you can have different security groups for different, as I said, Tomcat hosts might have 80, server might want to put on 80 or whatever. So good stuff. Another thing interesting is status build. So it goes through two statuses, build, and then hopefully running. The other one is called error, which is a bad one. So now we have the other one. We have SVChuck. It's active. Good. That's its thing. I went there. So you have to make the security groups we talked about. We want to log in. So it might be helpful to have two, which is SSH. And we put it on default. So remember earlier it was a security group default. So that's root already exists because I tried that earlier. And then kind of SSH. So it's called Ceros. And say yes. Then we need a password. when you are in this VM, you can do simple stuff like Cinder on home zeros, which is of course is empty. That's only a demo kind of operating system. So it's very small, you can't do anything real with it. Why is that, people might ask? Well, unless you use VMware Workstation, if you run, so often people run the dev stack inside a VM, like I run it inside my VMware Workstation. And the problem when you run inside VM is that a lot of those virtualization software don't carry through the hardware acceleration. So everything has to be done in software. So if you don't do something real like a big Linux system, all simulated in software, that will be slow. So yeah, that's why I have zeros, because that's not as slow. So I said, once you have, on the other hand, if you buy VMware Workstation, then you carry that through. Hopefully, all hoping that the other one, all being on VirtualBox, we learned that trick too. So good. Because they could use bacon for free, which is we'll talk about later. Okay, it's break time. Just phone out here.
Sure, we can break now.
Let's break now.
We have more to come after the break.
More to come, yeah.
Okay. So let's go ahead and take a 10-minute break. It's about 5 to 8, so let's start at 5 after. There are restrooms right behind you down that